Do not miss any of our cool videos. Subscribe to our channel for latest updates. Click on the bell icon now.
Hello and welcome to this video on advancements in machine learning. I'm sure you have heard a lot about machine learning, artificial intelligence, deep learning, and such similar words. And many of you may feel that machine learning is a sort of a magic wand that can do everything you want. There is a lot of talk regarding high paying jobs, answers to all solution problems, and so on. But what is machine learning exactly and what can it do? In this video, let's dive a bit deeper and demystify what machine learning is and what all it can do. So in this video, we shall see what is machine learning versus traditional learning, advantages and shortcomings, and some recent applications. Now what is machine learning? For a long time, modeling has been one of the prime things we have done to solve our problems. In order to understand phenomena around us, we have come up with models on our own through careful introspection to match the expected output and predict output on new data. We have used machines for the same as well. We feed them with a model, give them the inputs, and they return the output. But due to several factors like excess data, complex interactions, and lack of insight in technology, it becomes difficult to come up with such models on our own. Therefore, over the years, scientists, statisticians, engineers, and programmers have developed techniques through which machines can help to detect these underlying models on their own. In this way, machine learning was born. But what is machine learning? Machine learning is the science of giving computers the ability to learn without being explicitly programmed. What do we mean by that? Instead of giving them the model itself, we feed the machine with techniques so that it is able to attempt to generate generalized underlying patterns and distributions and make accurate predictions on unseen data based on a possible model candidate. Let's analyze the difference between traditional learning and machine learning in a bit more detail. In traditional learning, we feed the input to our model, which is loaded onto a machine, and the machine gives us the output. However, in case of machine learning, the data and its associated output is fed to the machine, which generates a suitable model. The machine then uses this suitable model along with some new data to generate its corresponding new output. Advantages of machine learning. Firstly, ease of trend and pattern identification. Machine learning has the ability to detect trends and patterns in data given to it easily and effectively, provided it is sufficient. This allows machines to generalize and create a possible model. Secondly, automation. All of this is automated and the machine does it on its own with minimal human interference. Hence, it is free from human errors. Thirdly, flexibility. Machine learning techniques are designed not just for one problem, but a large class of problems. So a single machine learning model can be given different data and it will make new accurate models. Also, the machine can adapt itself in case new data is given to it. And fourth, continuous improvement. A machine can improve continuously based on its previous performance. There are certain feedback mechanisms as well in order for machines to give better and better models that fit more closely to expectations. However, Machine learning has also certain shortcomings as well. First, data requirement. In order to generate a generalized model, it needs loads of data for the underlying trend to be evident. Otherwise, it won't generate the expected output. Second, time and resource requirement. Generating such a model needs abnormally large amounts of time, space, and processing power for machine. Sometimes it may take hours or even more for the machine to train on data. Third, algorithm selection. There are loads of algorithms available and all of them don't give the same accuracy. Unfortunately, there is no guideline to help us select which algorithm to use, and the person must try all the available algorithms and select the best one. And lastly, error proneness. A machine learning model is error prone due to two reasons. Firstly, the data needs to be as accurate as possible, else the model may catch the wrong trends and create inaccurate models. And second, while the machine can detect the trend effectively, in case of noisy or insufficient data, the trend may be different than the desired one, amounting to differences in the resulting outputs. Recent applications in machine learning. Machine learning has a variety of applications, not just in conventional computer science fields like recommendation systems or computer vision or robotics. It can also be applied in other fields as well. In this video, we will be discussing two of them, polypharmacy and gravitational lensing. Polypharmacy study. The polypharmacy case study has been picked up from the paper Modeling Polypharmacy Side Effects with Graph Convolutional Networks. You can find out more about this case study through this paper. As we know, there is a high risk of side effects when we use drugs, but in several cases, using a combination of drugs may also cause side effects even if they individually don't. However, such cases are very rare to find because there are very few documented cases available, and the combinations are usually not administered to patients because it is usually not required. And however, many of such combinations are unknown and might go unnoticed, or the documented side effects may be suspected to be caused by some other reason rather than such combinations. Therefore, we use machine learning so as to find new combinations of drugs causing side effects. Data and approach. The data on interactions between drugs and proteins were based on several databases and recorded. It contains 964 side effects, 645 drugs, 19,085 proteins, and several drug protein and protein interactions. Now, the data was made into a graph where the vertices denote molecules and edges denote interactions. This paper attempts to find new possible edges between drugs using existing edges. In other words, it aims to find new interactions between drugs that can lead to side effects based on the existent interactions causing the similar things. For that, the researchers used a graph neural network called Decagon. Evaluation. The resultant model gave 80% accuracy in side effect prediction, which is quite impressive considering that most of these predictions are unknown. Additionally, 5 out of the top 10 most likely combinations of drugs causing side effects has been backed by literature as shown. For instance, sarcoma is caused when pyrimethamine and aliskiren are administered together, and it was referenced by Stage et al. Second, we move on to astronomy, gravitational lensing. The gravitational lensing case study has been picked up from this paper. You can find out more about it by checking this paper. A modular deep learning pipeline for galaxy scale strong gravitational lens detection and modeling. What is gravitational lensing? Gravitational lensing is based on Einstein's theory of general relativity, according to which gravity can bend light. A massive object with a strong enough gravitational influence can produce a noticeable bend in light's path, causing it to appear from somewhere else. The image on the right has been taken by NASA ESA Hubble Space Telescope. Over here, towards the bottom right, you can see a reddish white circle along with a blue ring around it. This is a case of gravitational lensing. The reddish white circle or blob at the center is a massive galaxy, but the ring around it comes from a galaxy behind it and much further away from the Earth. The gravitation of the former has caused the distortion in the path of light coming from the latter, creating and distorting it into a ring-like structure. It is used in various applications such as studying massive mass concentrations which are usually too far or too faint to study and studying distant galaxies magnified with this lens. However, there are millions of images of space that we have collected over the years, and new data is being constantly generated. Out of them, there are a large number of possible candidates of gravitational lens as well. And it is hard to quantify each and every possible candidate. Also, we don't have sufficient cases of gravitational lens since only a few of them have been properly documented and identified and studied. So we have a lack of data representing what a gravitational lens should look like. So on the basis of current understanding of physics, we have generated synthetic data and created a gravitational lensing model and which can detect gravitational lenses using machine learning, and it is also able to study its properties. We have and the paper has used has first denoised and deblended whatever the images are there, basically removing the noise which is present in images, and then it used deep variational informational bottleneck deep VIB and modified ResNet 101 for classification and regression. These models are some of the recent models which have been built up in machine learning. The resultant model has a whopping 94% accuracy of detecting a gravitational lens and a mean average error of 0.01 with normalized data using deep VIB. I hope that this video has made you aware and understand what machine learning actually is and what are its capabilities. Thank you.